Introduction to the surface of Proxima B. An image that comes from the James Webb Telescope has essentially provided the clearest picture of Proxima B in history. Stumbling upon amazing knowledge about a potentially tenable exoplanet obliges us to embark on a journey through space to discover the mysteries of Proxima B, and to determine whether it might be the next Earth. We ought to take off into the vast expanse of space, where there is a mysterious planet in the habitable zone of its star, Proxima Centauri. This planet is unlike any ordinary rock. It's real, Proxima B. Discovered just 4.2 light-years away from us, this planet is covered in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? However, Proxima Centauri B is not the only one in that system. The red dwarf star has a companion, Proxima Centauri C. Who knows what additional mysteries the galaxy holds? We might have a second companion we haven't discovered yet. Proxima Centauri produces approximately the same quantity of energy for its planet as Earth receives from the Sun. Could this truly mean that there may be water, even life, on its surface? As we explore beyond our own solar system, we encounter an entirely new universe of planets, exoplanets that orbit stars other than the Sun. With 200 billion stars in the universe, there are countless opportunities for exoplanets. Some even wander freely, untethered to any star, like wandering travelers in space. One of the most groundbreaking and striking exoplanets is Proxima Centauri B, a captivating planet with a year that lasts only 112 Earth days. Its distance from its star is generally closer than Earth is to the Sun. One side of the planet is frequently bathed in sunlight, while the opposing side remains in eternal darkness. Let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri system, which includes 3 stars, Rigil Kentaurus, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, also known as Alpha Centauri C. Together, these stars form the closest star system to our solar system. The 2 stars, Rigil Kentaurus and Alpha Centauri B, make up a binary system called Alpha Centauri. These G and K-type stars are part of the constellation Centaurus and are among the 3rd most brilliant stars in the night sky, with a peak luminosity under 2.7. Proxima Centauri is a red dwarf, an M-type star found 21 light-years from the other 2 stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima is Latin for the closest. It was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it cannot be seen with the naked eye, having an apparent magnitude of 11.13, significantly fainter than the human eye's limit of 6.5. Nevertheless, Proxima Centauri still exists as a star worthy of investigation. Red dwarfs like Proxima Centauri are some of the most energy-efficient stars. They may not produce a lot of energy, but their internal convection processes keep them shining for trillions of years. Proxima Centauri will remain a main-sequence star for another 4 trillion years. However, the habitability of a red dwarf like Proxima Centauri remains uncertain. One challenge is that it is a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone would be much closer than the Sun's, projected to be somewhere in the range of 0.23 to 54 cents. But it's not as comfortable to live in as it appears. Proxima B endures intense bombardment by ultraviolet radiation from its star, radiation much stronger than what we receive from the Sun. It's so extreme that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may lack a vitally important environment to regulate temperature and maintain a surface that supports liquid water. Without these conditions, life would be nearly impossible. So, while Proxima B might look like Earth on the surface, it is far from being able to support life. Scientists continue to exercise caution. Numerous factors make it a hostile place. Still, Proxima B remains a mystery. One tool that has garnered astronomers' attention is the James Webb Telescope. Years after initial anticipation, the telescope was finally launched in late 2018. It is helping us determine whether life is possible on Proxima B. However, as with all science, things are never as clear as they appear. Several changes were required to ensure that the James Webb Telescope delivers accurate images. As Harvard theoretical physicist Abby Taber explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to capture this infrared light, to detect patterns that could confirm the presence of water or an atmosphere. But what if the atmosphere isn't conducive to life? the presence of an atmosphere doesn't guarantee life. Astrophysicist Ed Turner of Princeton University cautions that Proxima B could be like Venus, with a thick atmosphere significantly denser than Earth's and extreme temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its difficulties. But the James Webb Telescope holds promise. With mounting costs, space scientists are feeling pressure to find new ways to observe planets like Proxima B. Much is at stake, but the potential rewards are greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet with life-sustaining potential, is a pursuit worth chasing. If Proxima B proves to be habitable, might we one day visit it? It's the closest exoplanet to us, making it practically like exploring our own backyard. Even more exciting is the fact that it is nearly the same size as Earth. Its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it a perfect target for our search for life beyond Earth. Although we can't go there yet, it's definitely on the radar for future interstellar missions. As technology advances, it becomes one of the most exciting endeavors in space exploration. However, reaching Proxima Centauri would currently take 75,000 years using a spacecraft like Voyager 2. Nonetheless, a solution has been proposed: solar sails. Using extremely thin sails, a spacecraft bound for the Alpha Centauri system, and Proxima B, could be propelled by solar pressure. This would eliminate the problem of running out of fuel. Here's something even cooler: this cutting-edge technology could give us real-time perspectives on the possibility of life on other planets like Proxima B. However, like any ambitious effort, there are limitations. For instance, an atmosphere doesn't necessarily ensure life. Proxima B could resemble Venus, with intense heat and an unwelcoming atmosphere. Furthermore, the James Webb Telescope can detect such emissions if the planet achieves only 5% brightness on its daytime side. That may not seem like a lot, but for a star dimmer than our Sun, it's significant. If Proxima B had advanced civilizations, they might even use orbital mirrors to reflect sunlight from the day side to the night side. How cool is that? The discovery of Proxima B has captivated scientists and space enthusiasts alike. But what do we know about them? One type of planet that has captivated astronomers the most is the Earth-like exoplanet, planets that orbit within the habitable zones of their stars and might possess the right conditions to sustain liquid water, a vital ingredient for life as we know it. Proxima B is at the forefront of this exploration. While it remains shrouded in mystery, the prospect of uncovering its secrets continues to fuel scientific curiosity and technological innovation. Each data point captured by telescopes like the James Webb brings us closer to understanding whether this distant world harbors oceans, weather systems, or perhaps even biosignatures, clues that life may exist or once existed there. However, the journey is not purely scientific, it's also philosophical. The discovery of even microbial life on Proxima B would force humanity to confront profound questions. Are we alone? Is life a cosmic accident, or a common outcome of planetary evolution? As we peer deeper into the cosmos, planets like Proxima B serve as mirrors, reflecting not only what might be out there, but also who we are as explorers and thinkers. They ignite our collective imagination, inspiring everything from academic research to science fiction, and beckoning us to venture beyond the safety of our solar system. In the grand theater of the universe, Proxima B is a compelling character, enigmatic, possibly life-bearing, and tantalizingly close. As technology advances, missions grow bolder, and understanding deepens, one day we may reach this world. And when we do, the story of Proxima B may not just be about the planet, it might be about our own evolution as a spacefaring species. Until then, Proxima B remains a celestial lighthouse, a silent, glowing question mark in the night sky, calling out to the next generation of dreamers, scientists, and explorers to uncover its truth. An exoplanet that has drawn attention is a gas giant, which is a target of space scientists. The chemical makeup of these planets is similar to Saturn and Jupiter, but they are much larger. Some of these monstrosities are named super Jupiters, and are larger than even the largest planet currently in our solar system. Not only that, but there are also some hot gas giants, like Jupiter, which are extremely close to their host stars, existing in a scorching world with temperatures that could melt metal. Imagine seeing one of these planets in close proximity, with its violent storms and extreme heat. In addition to gas giants, Neptunian giants are also found there, exoplanets with sizes comparable to Uranus and Neptune, as well as the hot Neptunes and small Neptunes, which are smaller and closer to their host stars as opposed to their gas giant relatives. These planets are often shrouded in mystery, despite the difficult atmospheres both to study from afar. And please do not forget about the planet-like exoplanets, which resemble our own planet. They come in various sizes, ranging from 2 times smaller than our planet. There are even super-Earths, which have masses that are more than twice ours, but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is considered a super-Earth, with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still far enough away to be considered to be in the zone of habitability. Proxima Centauri b isn't alone, it has an accompanying Proxima Centauri c, much farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more interesting about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the existence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of a different planetary companion. If confirmed, this planet will be known as Proxima Centauri d and will be roughly the same size as Mars or Mercury. Imagine a life where the night sky is brimming with stars and countless different planets, each with its own distinct characteristics. The universe's orbits are full of surprises, and exoplanets are one of them. With brand new findings being made constantly, it's an exciting time to be a space scientist. While we don't yet have an accurate count of exoplanets, we do know they exist, just as we are familiar with the stars that illuminate them. Exoplanets, on the other hand, are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, as a result of technological advancements, imaging of exoplanets is now possible. For a direct image of an exoplanet, it needs to be big enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and visible from Earth. These restrictions limit the number of exoplanets that can be directly imaged, but they provide a fascinating glimpse into the characteristics and components of these distant worlds. Exoplanets are most frequently discovered through their modifications induced in their host stars. A planet's gravitational pull on an exoplanet causes its host star to wobble, and this can be determined by radial velocity. The Kepler Space Telescope utilized the transit technique, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a few amusing facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that in the TRAPPIST-1 system, there are 7 rocky exoplanets with water on their surfaces? Exoplanets like those in our solar system can also have natural satellites, with more than 1 exomoon. With more than 4,000 discovered exoplanets, we are aware that they are abundant throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to locate, but numerous other exoplanets remain to be discovered. NASA's James Webb Space Telescope is unveiling the secrets of the universe, one discovery at a time. This remarkable telescope has been gathering information and taking stunning images of the universe, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides important information about the formation and composition of the planet, offering us a glimpse into the mysteries of this gas giant planet. It orbits a Sun-like star 700 light-years away, and this finding marks a significant step forward in the search for life on other planets. NASA Administrator Bill Nelson stated that this finding would supply us with a new way of looking at the universe that has never been witnessed before, sparking excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy taking stunning photographs and gathering data about the universe in the infrared. The light from the young emitting object known as 110 IOS-4 illuminates the cool, wispy cloud behind the orange spots, and the material cloud reveals light from distant stars obscured by the ice in the cloud. The Webb's remarkable research was part of an Ice Age project that aims to investigate the formation of ice, from its creation to the development of icy comets. The James Webb Space Telescope, in its entirety, has imaged the inner workings of a dusty disk in the vicinity of a red dwarf star, capturing it for the first time in infrared light frequencies. The James Webb Space Telescope's observations have provided unparalleled insights into the dynamics of these distant systems. By capturing light in the infrared spectrum, the telescope has enabled scientists to study objects and phenomena that were previously invisible or too faint to detect with older instruments. This includes the study of young stars, the formation of planetary systems, and the detailed composition of distant exoplanet atmospheres. One of the key achievements of the James Webb Space Telescope is its ability to observe exoplanets in the habitable zones of their stars, where liquid water could potentially exist. This is crucial for understanding the conditions necessary for life elsewhere in the universe. As we continue to uncover more about these distant worlds, the telescope's advanced technology will help answer questions about the potential for life beyond Earth. Moreover, the Webb telescope's ability to capture high-resolution images of distant galaxies is transforming our understanding of the early universe. By studying galaxies formed billions of years ago, scientists can better understand the processes that led to the creation of stars, planets, and galaxies, offering new perspectives on the origins of the cosmos. As the James Webb Space Telescope continues to explore the far reaches of space, it promises to push the boundaries of human knowledge even further. With every new discovery, we come closer to understanding the fundamental questions about the universe, its origins, its structure, and its future. This era of exploration, driven by cutting-edge technology and a renewed sense of curiosity, is an exciting chapter in the story of human discovery. As we uncover the secrets of exoplanets, distant stars, and galaxies, we are reminded of the vastness of the universe and our place within it. And with each new revelation, the excitement of space exploration only grows, as we continue to chart the unknown and seek answers to the mysteries of the cosmos.